Welcome back. Today we're doing Linux file and directory permissions. We're explaining Linux file and directory permissions. This video is part of the Red Hat Linux Enterprise training course. So with the hot topic, Linux file and directory permissions, we start with permission classes, permission types, modes. We're going to go over the concepts and then we're going to experience or use the commands on Red Hat Linux to understand how we can manipulate and change file permissions, file and directory permissions. Okay. So the first thing we have about Linux file and directory permissions is permissions classes. So it's important to understand the terminology of each of these concepts. So the classes, the permission classes are the users. So U stands for users. G stands for group and O stands for public. So technically, if you are a user in Linux and you have a user, say Mike, so you will be user Mike, and suppose we have a group called admins. The admins is the group, and O stands for public, which means everyone other than you as Mike and admins as a group. Permission types, as all of you know, we have the read, we have the write, and we have the execute. So read to read files, write to modify on the files, execute to execute binaries, or to cd to directories. Permission modes. So as you will see, when we learn how to add permissions or revoke permissions, we will use the plus for the assign and minus for revoke. Okay. Let's see how we can change permissions now. So before changing permissions, we got to understand how to change them. So we have two methods. We have the numeric method, where we will be using numbers to change the permissions, and we have the symbolic method, where we will be using a plus sign, and we will use the letters in the permission classes. So as you can see here, 0, if we assign 0, it means we don't assign permissions to the user or the group. 3 hyphens means there are no permissions on the file. So next we have 1. So 1 is only execute permissions. So when you see this, it means that 2 hyphens and 1 x, it means that only execution permissions. Next we have 2 for write. If we assign 3, it means we are assigning both write and execute. If we assign 4, it means only read. If we assign 5, it means only we assign read and execute permissions. 6 for read and write, 7 for read, write, and execute. Let's demonstrate an example of how to use the numeric method in changing the permissions. All right, so we are now in the Red Hat machine. I'm going to create a file called touch example1. Oh, permission denied. The first thing I got is permission denied. All right. I think I'm going to switch to the root user. It's better to explain things. So I'm going to switch to root. Okay, so touch example1. Let's examine the permissions on the file. So we have example1. And as you can see, the file, as you can see, the first slot is for the user, the second slot is for the group, and the last slot is for the public. So basically, the first slot here, we have read and write. So it means the root user can read and modify or write on the file. The group, which is root here, they can only read, and anyone else can only read on the file. So say I want to change the permissions on the file using the numeric method. So I would use the command chmod, and then I would write the numbers. Let's get back to the board and see what we want to do. So basically, I want to change the permissions so that the group, okay, can not only read, but also write. And I want to also make the owner not only read and write, but also read, write, and execute. And I want only to leave the public permissions as is. So keep it as are. So it means if we get back to the table, we need to add the execution bit here for the owner. So we would use the number here. The number is 1. So which means that in order to let the owner execute, we need to add 1 to the current permissions. The current permissions are read and write here. So plus that plus 1, 6 plus 1 is 7. So read, write, and execute stands for 7. So I would say 7 for user. Now for the read, I have only read, but I want to add the write permission. So I would get back write only 2, okay? The read only, we have 4. So if I want to assign read and write, I would add 4 plus 2, which equals to 6. And leave the public permissions as is. So leave it as read only. Read only bits are 4, so 764. And the file name. Let's examine the permissions now. So read, write, and execute for the owner, read, write for the group, and write for read for the public. That's for file permissions, for changing the file permissions with the numeric method. What about directories? So if we see the back, examine the permissions of that directory, we see directory start with D. So the current permissions are read, write, execute for the owner, read, execute for the group, and execute for public. Okay, which means that everyone in the system and also non-system users can cd to the directory. Say I want to change the permissions in that directory. I have 2 cases. If I want to change only the directory or the directory and its sub files and directories, so the case is different. So if I want only to change the permissions on only the directory, I will use chmod the same way with changing the file permissions. If I want to change the permissions on the directory and its subdirectories, I would use -r for recursive. I want to change not only labs permissions, also the example 1 file under labs. So say I want to put the same permissions I put on the file, put them here on the directory. So I would use 764. Or let's make a bit of a little change. So here 76. Let's say I want to make the directory modifiable by everyone. So the current permissions are execute. If I want to add the W, I need to get back and examine the numbers. So X is 1, W is 2, 2 plus 1 equals 3. So 7x3 for labs. What's going to happen now? So now, as you can see, WX, which means that the public can now write on that directory, which is bad practice, but this is only for demonstration purposes. Now, if I cd or examine the permissions on the file itself, you see only the file, also the file has its public permissions changed to include write permissions because I used the -r. Okay, that's for the numeric method in changing the permissions. Let's now get back and examine the symbolic method. So the symbolic method, you don't need to use both of them, right? You can only understand one, master one method and work with it. But it's better to, since this is training for the Red Hat certificate, it is a good idea to understand both. So we have the symbolic method. Symbolic method works with a plus for assignment and minus for revoke permissions. And also we will use the permission classes here to add or revoke permissions. Let's take an example. Back here, cd to labs. Else we have the example 1.txt. All right, let's say I want to add permission, right? Let's say first examine the permissions. Good idea to examine the permissions first. So read, write, and execute, read, write, write, execute. Let's say I want to revoke the write permissions from the public. So what I would do, I would say chmod, okay, public is O, and then I would use minus for revoking the permissions, and then I would assign write, okay. So here I am assigning, or I am denoting the public and also removing the permissions from the public. The permissions are right. The file is example. What's going to happen now? ls-a. You see now the right permission has been lifted from that on the file from the public user. So now if you would like to add it back, I would say chmod O for public plus for add, W for write, and the file ls-a. So we return the permissions back. Let's say I want to remove the write permissions from the group. So what I would do, chmod group is G dash for revoke, W for write, and the file. As you can see now, the group has only read permissions. Simply that is how the symbolic mode works. Okay, so by now you have got an idea how to what are the permission classes, the types, the modes, how to change them using the numeric and the symbolic method. Now let's understand the umask. What is the umask? And what are the initial file permissions? So let me get back to demonstrate this. Let's create a new file, touch example.txt. Examine the permissions. As you can see, the permissions on the file are a bit different from the previous one, and that is totally justifiable because we have changed the permissions on the file one ourselves. Now, what about these permissions? Where do they come from? These are called the default permissions, okay, and they are calculated by subtracting the initial permissions from the umask. Now, what is a umask? A umask is a value or 3-digit value assigned for the user and the root. For the root, it is 022, and for the user, it is 002. Now, you're going to ask me, what is the use of umask? The use of umask is to calculate the default permissions. Now, by default, the initial file permissions for the file is 36. The initial directory permissions are 37s. So, if you want to calculate the default file permissions, for example, we would subtract the 36 from 002, which means we will get 6, 6, and here 4, right? 6 minus 2 equal to 4. So 664, let's get back to the table. 664 means read, write, 4 is read. If you get back, and indeed, these are the default permissions. If we examine the umask now, as you can see, the umask is 022. Now, don't bother with the leftmost 0, only focus on the 022, which is for the root user. Now, if I am not satisfied with the default permissions created by the Linux system, what I would do, I would change the umask. So let's say umask is 027. I'm not going to change them, but just I am giving an example. Now, when I put 027 as the umask, the default permissions will change to something else. Okay, let's take an example. The umask 027. All right, let's create a file now. Example3.txt. Examine the permissions. Now, example3 has different permissions, as you can see. So, example2 permissions are different from example3, although I didn't use chmod, right? These are the default permissions have been changed. So if I put the umask 027, and if I calculate the default file permissions, I would subtract 027 and 666, right? So the result is, if you did the calculation, you will end up with this with these permissions: read, write, read, and nothing for the public. All right, that's for the umask. I'm going to change the umask back to 022 umask. Okay. Let's talk about the setuid setgid, and sticky bit. So most of you, if you work in the pen testing, one of the privileged or one of the Linux privilege escalation methods is to abuse files that have the Setuid bit set, right? Why? Because the Setuid bit set is a bit set on files, especially binary files, so that when the file is executed by non-owners, all right, will be executed as the root user or as the owner. Say we have, let's get back. So we have a file called, so we have two users, the root and Mike. If we set the set bit on a file such as binary file whatsoever, right? Then Mike will be able to execute the file as the root. That's the meaning of setuid. Now setuid, the concept is the same, but instead of executing the file as the owner, the file will be executed as the group owner. Sticky bit is for public and shared directories to prevent directories from being deleted. Let's take an example. So if we ls-la user bin grep su okay, so this is the su tool, which is used to change from user to another user. As you can see, we have the S, the setuid bit, which means that if a non-root user, such as Mike, tries to use that tool, all right, they will be able to execute the tool as if the root user is executing the tool, right? Sometimes system administrators need this functionality to enable non-root users or administrators to use the binaries and programs efficiently. But you have to be careful when assigning the setuid bit to programs or binaries. Make sure that the program have the right permissions and make sure the program is up to date, doesn't have a public exploit, right? Make sure the security considerations are in place. So that is the setuid bit. Now the setuid bit works the same, but instead of executing the tool as the root, it executes as the group, which is root. Now, let's talk about the sticky bit. All right, so before talking about the sticky bit, let's take an example how to set the Setuid bit on the files. So, get back to labs, create a file called touch example binary. And if you want to set the S bit using the numeric method, you would say chmod plus 4000 example binary. Now, as you can see, it has the Setuid bit set. If you want to do that, or if you want to remove it, you would type minus. As you can see, it has gone. If you want to do that with the symbolic method, you would say chmod the user plus s example binary. ls-la. Now the Setuid bit set is presented. Now, say we want to do the same, but with the setgid. So, what you would do, instead of u plus s, you would use the g. ls-la. As you can see, it is here now. Okay. Now, what about the sticky bit permissions? If we clear, let's take an example for demonstrating the sticky bit permissions. If we go to ls-la temp, okay, so this is the temp directory. Okay, now to find out if a file has the sticky bit permission set, you have to examine the permissions, of course. As you can see, we have T, and here we have T. What does it mean? It means that this file, right, or this is directory actually, it means that this directory, all right, can be accessed, as you can see, by the public. But if the public tries to delete the file or the directory, we will get the write protected error. Okay, so if I switch now to my user, cd to temp, if I try to delete this one, rm, Unix, as you can see, you remove write protected socket, right? Why? Because it has the T bit. So the only use for this case, or the only use for the sticky bit, is if you want to share directories and files with the public, right? Such as file server or shared directory for a group collaboration. You would use the T, okay, just to prevent other users, non-authorized users, from deleting the directory. Since this is a shared directory, or since the file or the directory that you are about to create is a shared, you have to set the read, write, execute permissions on the public, so they are able to modify and read on the file. Otherwise, it's not going to be shared, right? So in order to protect the directory from being deleted, you have to set the T, or the sticky bit. So that was about the permissions in a very nutshell. Okay, I hope you find this tutorial helpful, and see you in the next video.